Hello and welcome back. Today we're going to be doing a free fall practice problem. Let's say this is the surface of the earth and I sitting right here, and from this point I throw an object. Let's say I throw a guitar upward at a speed of 90 meters per second. I'm super strong, so I can totally do that. How high does it go? So, what do we know here? We know acceleration because it's g, nothing else is working on it. We know initial velocity, and although you may not see it, we also know final velocity. Now, why is that? Well, when you throw something up into the air, and it goes up and up and up and up, acceleration is always pointing down, which means this object is going to be slowing down as it goes up, right? Right. What happens if you can't slow down anymore? Then what? Then our object is at rest, 0 meters per second, at the very peak of its height. But we still have a downward acceleration, right? What is it doing now? Well, it's pushing it back down to the ground. So, in our case, if we're trying to find our delta y, how high this guitar goes up into the air, what can we use as final velocity? We can use 0. We can use 0 because at the very tippy top of this guitar's journey, it's going to reach 0 meters per second. Right there, right at the very top. For a tiny, tiny, tiny time, it'll be 0 meters per second. And then it'll start coming down, right? So, what equation can we use? Well, there's one variable in these big three equations that we don't have a need for and don't even have. And that's time. So we can get rid of number 1 and number 2. And the only equation that works is number 3. Because there's no time. We don't worry about time. It's fine. So v squared equals v naught squared plus 2a delta y, not delta x. I define y as the vertical and x as the horizontal, so I always change delta y to delta x, and you should too. It's good practice, especially when we move forward and have to use both x and y. We know here. We know v squared is going to be 0 meters per second squared. Very simple. We know v naught squared, 90 meters per second squared. 2 is going to remain the same. And a. What is a? Well, we know the value of g is 9.81 meters per second squared. That's constant with gravity near the surface of the Earth. But now hold on. Is it going to be negative or positive? Well, in this case, I'm treating the upward direction as positive. I'm not changing anything. And you can tell that because I kept 90 as positive. 90 is going up positive. And our acceleration is going in the opposite direction because it's gravity. It's pulling down towards the ground. So in this case, we're going to use negative 9.81 meters per second squared, delta y. And now we can just solve for delta y. So let's do that. Take out your handy dandy calculator. We have negative 90 squared on this side, 2 negative 9.81 on this side, delta y. That ends up being 8100 equals 2 times 9.81. And this is negative 19.62 delta y. And delta y is 8100 divided by 19.62, 412.84 meters. That means at the very tippy top, that guitar went 412.84 meters above the surface of the earth. Like I said, I'm super strong, so this is entirely realistic. I am the strongest man on earth. All right, that's the problem. Thank you for watching and happy learning.